Hi there once again and welcome to another Expresso mechanic tutorial. And in this one we're going to be rigging what you see on the screen, which is a dynamic ratchet setup. Now the whole thing is based around dynamics. The only thing that I've got a little Expresso expression for is the pivot hammer, what I'm calling the pivot hammer here. And it's a very simple expression. Other than that, it's just rigid body dynamics and connectors. And it works beautifully, as you can see. So that's what we're going to be about. Now the model for this, or the scene file for this, I have made available, and I've put a download link from Dropbox in the show notes so you can pick that up before we start doing the tutorial. But anyway, that's what we're going to be about in this one. So without further ado, let's see if we can make this happen. The first thing to do is hit Command D. And we'll go into our project settings, click on the bullet tab here, and then the expert tab. Now, two things we need to change: the collision margin and the scale. The collision margin we need to set to 0.2 on this occasion, and the scale to 5 centimeters. Other than that, everything else can be left the same. That's got the first little part of this done, and then we can move on and think about making a few of these objects dynamic. If we start with the top here, which is this top pawl, what we'll do is add a bullet tag, and it will be a rigid body. The dynamics are set okay, we don't need to change anything in there. The collision though, this is where we do need to do some work. For a start, the inherit tag, we're going to make that a compound collision shape. Individual elements we can switch off, it doesn't really matter about that. The self collisions, we can switch that off. The use deformed object, we can switch that off. And this keep soft body shape, we don't need to worry about any of those. The shape, we need to make moving mesh. And the size increment we're also going to use, and we're going to make that minus 0.2. because we're trying to minimize the gap between the pawl and the ratchet. Everything else we can leave. The bounce is fine, the friction, they're both fine. We can leave those as 5% and 90%, and we don't need to worry about the collision noise. That gets that set up. Now, we also need the same thing on the bottom here and on this cylinder, which is effectively the axle for the ratchet. So we can hit Command and drag this one onto here, and then do the same and drag this down onto our cylinder. Just place it there for the sake of tidiness. Okay, so that completes the first little part of our dynamics. The only thing we need to do now is add another tag, and we need to add this onto our pivot hammer here. So with the pivot hammer selected, we can grab a hold of, once again, a bullet tag, but this time it will be a collider body. So we'll drop that into there. And our collider body just needs to be set up in a very similar way, actually. We need a compound collision shape for the inherit tag. The individual elements, we can leave that as all if we wish to, or we can switch it off. We'll just leave it as it is. Again, we don't need the self collisions, we don't need use deformed objects, and we definitely don't need keep soft body shape. It will be a moving mesh. We don't need to worry about the size increment. We'll set these differently though. We'll make this 5 and we'll make this 90 so that it matches up with everything else, and the collision noise we'll just leave as it is. So that completes the dynamic setup. All of our objects that need to be dynamic are now that way. And we can move on from here, and we can think about adding some connectors. We'll bring in our first connector. A little bit too big, so in our display we'll make this 5. That's more like it. And this needs to connect this axle null to the cylinder. They need to be connected together. So we'll come into our object tab here, bring the axle in and the cylinder. Everything is set up the way it needs to be, so we don't need to change anything. If we just hit play, we can see that that's trying to rotate and things are trying to move. They're not going to yet, which is exactly what we need. So that's all good and that's doing what it needs to do. Moving on from here, we'll bring in a second connector. And once again, it's way too big. We'll make this one about 2. And we can drop this into T here. Now T is just a null that's set up at this hinge point here. If we then 0 our connector out, it will be in the right place. We can then put it up here, and the next thing to do, select the object tab, bring in the top, and we'll also bring in the pivot hammer. And that's the connection that we need. We need it to be connected to the pivot hammer. So it's not a case of connecting it to T here. At first glance, it might look as if that's the way you need to connect them, but it isn't. You must connect it to the pivot hammer. Okay, so that's our top done. Now, if we command drag to copy this connector so that we've got connector 1, we can then just clear this out. And what we're interested in here, well, before we go any further, we'll just drop this into B and 0 that out. So that's in the right place. Drop it back up here. Now what we're interested in is the bottom, connecting that to the pivot hammer. So once again, our object tab, what we'll do is drop the bottom into here and the pivot hammer into here. And now they're connected, and that should all be working perfectly well for us. So we've got, let's just, in fact, just try playing. Again, we can see that that's all going to work okay. So that's our dynamics and our connectors all set up and ready to play. The next thing we need to do is work with this Expresso null here. We'll put a programming tag Expresso on this, and then we can start work. It's very, very simple. As I said, this expression, there's nothing really to it. We need a time node, so we'll bring one of those in, and as per usual, remove the time port. Let's just get rid of that and bring in a frame port. And then we need a range mapper. So we'll come down to calculate, range mapper, bring one of those in. Our good old trusty friend. Connect the frame port to the input. And then we can think about working in here. Now our input lower needs to be 0, our input upper 60. So we're going to be doing this over 60 frames or 2 seconds. And then our input range, we can leave it user defined. Our output range, we can make degree. And then we can think about what we're going to be doing in here. Now, this pivot hammer, if we select that just briefly and go into its coordinates, we can see that it's set at -15 degrees. So that's the angle that it's at here. And that puts the top pawl at the end of its stroke and the bottom pawl at the beginning of its next stroke. That's how I've set this up. And if you do make one of these yourself at any point in time in the future, make sure you set it up like this. Don't set the pivot hammer level. Don't zero it out. It'll cause you more problems than it solves. That's just the way I found when I was doing this, because I did try to do that originally. But anyway, that's the setup for that. So we've got -15 degrees in there. So in our range mapper, we know that our output lower needs to be -15 and our output upper needs to be 15. So that's its range of, or its pivot range, let's say that. So that sets that up. Now the next thing that we need to worry about is the spline, because that's going to be important. But also before we do that, we'll just check on this modulo, because I want this to repeat. So we'll put the modulo on. In our spline, we can just click, click, and click just to add, or command click I should say, just to add 3 points. And then we can think about what we're going to do with them. Now the center point is the most important. We want this to be 0.5 along the x-axis, and we want it to be 1 on the y, so that we're creating a bell curve. And then we can think about working with our tangents. So we'll make this 0.25, and we'll just say the same here, minus 0.25. And that creates the perfect bell curve. That's going to give us the result that we want. So that's the setup for the range mapper. Output range degree, click on the modulo, make sure that's checked on. Input lower 0, input upper 60, output lower minus 15 degrees, output upper 15 degrees, and then a bell curve for your spline. And that's finished that. And then the final thing we need to do is bring in the pivot hammer. And at the input, we need to give it a rotation B port. So just give it that, rotation B, connect these together. And that completes the Expresso. It really is that simple. So let's just close the window. Now, it's a bit of the moment of truth. Let's see what happens when we play. And look at that. Superb. It all works. And it's a really nice piece of motion because it really does work like the real thing. Because if you think about a real sort of mechanism, perhaps within a clock or something like that, you do get this slight backward movement of the ratchet. You know, it really is a nice movement, that. Very, very credible. And of course, if you wanted to take things slightly further, what you could do, you could put like an end loop on here and then create, say, a pump mechanism. It's similar to a beam engine idea. You can have a pump that pumps up and down and makes this thing move. You know, that could be done. Or you could even use, say, I don't know, a crankshaft if you wanted to, couldn't you? Or even a cam. You know, there's a number of different ways that you could make this move if you wish to make the mechanism slightly more complex. And then I don't know whether it's possible to do it with the new dynamics, but you could possibly attach a rope here and have a bucket on the end of it and have this lift the bucket. You know, that kind of thing could possibly be done with it. You know, there's a number of different things that you could have a play around with. But yeah, I mean, it's a really beautiful result that you get. I was really pleased when I actually made this and saw it working. I thought, yeah, that's really stunning. And then, of course, if you want to move it around, because of the way we've designed it, and I've put it into a null here, you can place this anywhere in the scene and it will still work. So there's no problem with that. It'll just do it. So that all works really nicely. And then once you've got it placed in your scene, you can click on one of these, go to the cache, and then bake all, and that will sort it all out for you, and it should be fine. Doesn't take that long to cache, so I'm doing it in real time. Now, if you do get any problems with the cache, and I have occasionally seen them, we'll just let this play, see if we get it on this occasion. I just found something went a bit strange with the top pull. I just want to see if it does it here. But if it, yeah, there you go. It's starting to fall apart. Now, that is a bit weird. Now, what I found, if I clear the cache, if I just include the collision data, the second time I did this, it did work. I mean, it probably won't now that I'm doing this, but we'll just see if it does. We'll just bake all. So you've got to be a little bit careful with the baking. Sometimes it can be a bit finicky, you know. But anyway, let's just see if that fixes the problem. It did for me when I did it before, as I say. No, it's still like it, isn't it? So, I mean, the thing to do, I think the thing to do is just clear it all. Just take that off a minute. Take that away. Local coordinates shouldn't be the problem. But if you do get a problem with your baking, the best thing to do is just experiment with it and then see if you get any more problems. One thing you could possibly do, if we go, where are we? Command D, let's go back into here. You could possibly play around with the steps and the maximum iterations as well. Let's try doing 10 and 20 in there and see if that solves the problem. Let's just go back to here. We'll leave that as it was. We'll use cache data, we'll do that. And just bake all, let's see what happens. But yeah, I mean, it's just one of those things. Sometimes you need to play around with it and just make sure that it is going to work and do exactly what you want it to. Because of course, if you do want to use things like motion blur and all that kind of stuff, you might need to actually bake out. Let's just see if that makes any difference. Well, so far so good. Certainly better than it was before. Yeah. And we've looped, yeah. So that's working now. So yes, if you do get any problems with your baking, that's the thing to do. Experiment with this first, include collision data. If that doesn't solve the problem, Command D, and then increase the steps and the maximum iterations per step. That's the thing to do, and it should solve the problem for you. But anyway, I just thought I'd show you that because I thought it was useful information to give you. But apart from that, well, as you can see, we're basically at the end of the tutorial because I'm showing you everything I wanted to show you, and it all works fantastically well. So as always, I really hope that this has been of value to you and that it's inspired you and given you some ideas that you can perhaps incorporate within your own projects. And if it has, then please give the video a like. And if you haven't already, then please subscribe to the channel, leave a comment, and of course, ring the bell. And wherever you happen to be on social media, please do share this video because all this good stuff really does help keep the channel moving in the right direction. But anyway, that about brings us to the end of this one. So I'll see you very soon on the next tutorial.